Good morning. I am Felice Merra from Polytechnic University of Bari, Italy. I'm presenting you the work TAaMR, Target Adversarial Attack against Multimedia Recommender Systems. TAaMR is a novel framework to investigate the effect of adversarial perturbed product images on multimedia recommender systems, which exploit them to produce recommendations. To introduce the audience to the recommender system research field, I will firstly describe and motivate the proposed attack framework. Then I will present you the experimental setting and the discussion of the results. Finally, I will draw some conclusions and raise novel challenges. Here we introduce our work and provide the motivation. Nowadays, recommender systems are considered as the principal technical solution to assist users' decision-making process. They are gaining momentum as the overwhelming volume of items, services, and multimedia contents on the web has made the user's choices more difficult. Among them, collaborative filtering approaches and hybrid approaches have shown very high performance. For instance, John's recommendation list will be based on same listen tone preferences but also on visual features extracted from products. A multimedia recommender system, which is a class of hybrid recommender, combines pure collaborative filtering information, the S matrix, with multimedia extracted features. For instance, the image feature extracted from a convolutional neural network F. In the previous example, the product images stand for multimedia content. Unfortunately, malicious users may alter the classification extraction performance of a convolutional neural network by means of a human imperceptible adversarial perturbation. For instance, a common example is the one involving a panda classified as a gibbon after a small adversarial perturbation. In this work, we have studied the performance alteration of a multimedia recommender when an adversary performs a targeted adversarial attack on the input product images. Particularly, we have explored the attack situation where adversary's goal is to perturb images of a low recommended category of products, for instance, the 20th most recommended one, to drive them towards a target, very recommended category, for instance, the first or the second one. And in this work, we aim to answer two research questions. The first one is that, can targeted attacks against images of a low recommended category of products be exploited to modify the recommendation list and make that category more recommended? And then, what are the effects of adversarial perturbation for human perceptions? Now, I will present you the experimental setting. First of all, we have exploited two well-known datasets with images to simulate a recommendation scenario: Amazon men and women. We considered the clothing, shoes and jewelry category, since several works demonstrated the significant impact of visual features on users' choices in the fashion domain. The statistics of the datasets are depicted in this table. Then we have conducted the experiments on two attacks: fast gradient sign method by Goodfellow and an iterative version of FGSM, which is the projected gradient descent by margin, which is more successful than FGSM. Then we have evaluated TAaMR on two multimedia recommender, VBPR by et al., a state-of-the-art multimedia recommender model designed specifically to integrate visual feature extracted from a CNN, and AMR by Target Adversarial that integrates VBPR with an adversarial training procedure to protect the model from adversarially perturbed features. We have evaluated our attack strategy by proposing a Noia rank-based evaluation metric called category hit ratio to measure the fraction of attacked items in the top N list. Let C be the category of items to push and I see the set of items whose images are classified as C. Then we define this metric as the fraction of items in the top N recommendation list belonging to C, where it is a 0-1 valued function that is 1 when the item in the top N list is classified within C class, 0 otherwise. At the same time, we have conducted also visual evaluation with the PSNR and a more sophisticated matrix, which is the structural similarity index and the perceptual similarity matrix, that are used to mimic the human evaluation in an offline setting. And now we are ready to present the tested adversarial scenario. Firstly, we trained the recommender model exploiting the extracted visual feature on original clean images. Then, according to the recommendation list, we select the source and target class, which can be semantically similar, for instance, socks and running shoes, or semantically dissimilar, for instance, maillot and chain. We can now discuss the experimental results. The first research questions verify whether the application of targeted adversarial attacks against images of low recommended products alters the behavior of a multimedia recommender. This table shows the results for category iteration at 100. First, we observe that the proposed attack can be very effective in enhancing the recommendability of the source category. For instance, the combination Amazon van, VBPR, PGD with epsilon equal to 8 displays a 3 times increased category iteration. Then PGD is much more powerful than FGSM, also in the variation of the recommendability. And AMR is not completely safe. So we need more work to specify and propose more protected models. And at the same time, we go to the analysis of visual and human evaluation. We try to predict to what extent the applied attacks might be visible to online customers. Image distortion increases when the attack becomes stronger, as expected, but even in the worst case scenarios, all variously within their respective best ranges. For instance, the combination Amazon man, FGSM, and SSIM metric. Differently from the trend, only the perceptual similarity metric values show that PGD is more visible than FGSM. That is, CNN-based metrics might not be easily fooled, but humans do remain visually not aware of the attacks. We will show you an example of a product images socks before and after a PGD attack with epsilon equal to 8. In this case, the product has been pushed from the 180th position to the 14th one, and it clearly shows the effectiveness of the attack. So we can draw some conclusions and open future work. In this work we have proposed TAaMR, a framework to simulate targeted adversarial attacks against multimedia recommender. We can conclude that low recommended product categories becomes even 3 times more recommended by perturbing simply each images, and also AMR, an adversarial defended model, manages to slightly reduce the effectiveness of the attack. In future, we plan to investigate new attacks, investigate attacks on a single item within the same category, and prepare a user evaluation.